Right now, as you're watching this, the moon is leaving us. Not eventually, not theoretically. Right now, the moon is drifting away from Earth at 3.8 centimeters per year. Every single year, the moon gets a little bit further away, and there's nothing we can do to stop it. That might not sound like much. 3.8 centimeters, less than 2 inches. You probably won't notice in your lifetime, but over hundreds of millions of years, that adds up. And the consequences are catastrophic. In 600 million years, total solar eclipses will no longer be possible. The moon will appear too small in the sky to completely cover the sun. The last total eclipse will happen, and then never again. In 1 billion years, Earth's days will be 25 hours long. The Earth's rotation will have slowed so much that a full day-night cycle takes an extra hour, and eventually, if this continues long enough, the moon might escape Earth's gravity entirely. It could drift away into space, leaving Earth alone. Let me explain exactly what's happening, why it's happening, and what it means for Earth's future. Here's how we know the moon is leaving. In 1969, during the Apollo 11 mission, astronauts placed retroreflectors on the lunar surface. These are basically mirrors. Scientists on Earth shoot laser beams at these mirrors, and the mirrors bounce the light back. By measuring how long it takes for the light to return, we can calculate the exact distance to the moon, down to the centimeter. And we've been doing this for over 50 years. It's called lunar laser ranging, and the data is undeniable. Every year, the moon is 3.8 centimeters further away than it was the year before. That's 38 meters every 1,000 years, 38 kilometers every million years. Right now, the moon is 384,400 kilometers every billion years. That's 10% further. And that 10% changes everything. So why is the moon drifting away? It comes down to tides. The moon's gravity pulls on Earth's oceans, creating 2 bulges of water. One on the side facing the moon, one on the opposite side. These are the tides. But Earth is rotating faster than the moon orbits. Earth completes a full rotation in 24 hours. The moon takes 27.3 days to orbit Earth. So as Earth rotates, it's dragging those tidal bulges forward. The bulges are slightly ahead of the moon. This pull accelerates the moon in its orbit, giving it more energy. And when an orbiting object gains energy, it moves to a higher orbit, further away. At the same time, this tidal interaction slows Earth's rotation. The moon is stealing Earth's rotational energy and converting it into orbital energy. So Earth's days get longer, and the moon drifts away. It's a trade. Rotational energy for orbital energy. This has been happening for 4.5 billion years. When the moon first formed, it was only 22,000 kilometers away, close enough that it would have filled half the sky. Tides were hundreds of meters high. Days were only 5 hours long. Over billions of years, the moon has been slowly spiraling outward, and it's still going. Let's talk about what happens to Earth's oceans when the moon is gone. Right now, the moon is responsible for about 2/3 of Earth's tidal force. The sun contributes the other third. If the moon drifts far enough away, or escapes entirely, ocean tides will become much weaker. But tides do far more than just move water up and down coastlines. Tides mix the oceans. They bring nutrients from the deep ocean to the surface. Without the moon, Earth becomes Mars. Dead, frozen, lifeless. And let's talk about eclipses. Total solar eclipses are one of the most spectacular events in nature. The moon passes in front of the sun, blocking its light completely. The sky goes dark, stars appear in the daytime, the sun's corona becomes visible. But this only works because of an incredible cosmic coincidence. The sun is 400 times larger than the moon, but the sun is also 400 times further away. So from Earth, they appear almost exactly the same size in the sky. That's why total eclipses are possible, but as the moon drifts away, it appears smaller. Eventually, it won't be large enough to completely cover the sun. You'll only get partial eclipses, or annular eclipses, where a ring of sunlight remains visible. This will happen in about 600 million years. After that, no total solar eclipses, ever again. Humans alive today are living in a narrow window of cosmic time when total eclipses are possible. In the 4.5 billion year history of Earth, total eclipses have only been possible for about 2 billion years. We're witnessing something temporary, something rare. and in a few 100 million years, it'll be gone forever. So can we stop the moon from leaving? No. Tidal acceleration is a fundamental consequence of orbital mechanics and conservation of angular momentum. You can't stop it without violating the laws of physics. You could, in theory, slow it down. If you added mass to Earth, you'd increase its gravity and pull the moon back slightly. But we're talking about adding entire planets' worth of mass. Not realistic. Or you could speed up Earth's rotation artificially, giant rockets firing constantly to counteract the tidal slowdown. But the energy required would be astronomical, and you'd have to do it forever. So no, we can't stop it. The moon is leaving, slowly but inevitably. Here's the timeline. Right now, everything is fine. The moon is where it's always been in human history. Tides are strong, days are 24 hours, seasons are stable. So what does this mean? The moon isn't just a light in the night sky. It's not just a pretty thing to look at during a romantic evening. The moon is Earth's life support system. It stabilizes our climate. It creates the tides that feed our oceans. It keeps our days at a length that life can adapt to. Without the moon, Earth doesn't work. And the moon is leaving, not in our lifetimes, not in 1,000 lifetimes, but on cosmic timescales, it's happening fast. Right now, we're living in Earth's golden age, a stable moon, stable tides, stable seasons, stable climate. But that stability is temporary, and the clock is ticking. The moon is drifting away, and when it's gone, Earth's nightmare begins.